Welcome to this journey where we dialogue with thought and heart leaders to share their reflections on human condition and how to improve them.
There are many people who created many different kind of languages, and inventing new language has been a hobby of linguists. For an example, in Avatar movie, the director wanted to have a dedicated language for Pandora, and he created a language. So when they create a language, what do? They select a few letters, and those letters have pronunciations. Like Indian language, ka, kha, ga, gha, wo, cha, cha, ja, ja, ya, ta, tha, da, dha, na, ta, tha, tha, da, ra, pa, fa, va, va, ma, something like that. So they select some letters and then they build a grammar to link those letters and then they express. I never wanted to invent a new language, but it was during the course of our research we understood that if we want to make an artificial brain, then what we have to do is the material would vibrate and that would create the brain, that would analyze the dynamics, that would understand what I'm talking about, and that would give directly the output. If there is no algorithm, I need a language that will convert my my voice or my video or the chemicals I'm sending it to the system, any kind of sensory input into a very particular kind of input that the material or the brain jelly can understand and respond. If that is the condition, that I need a language of the materials, I need a language of the materials. Language of the materials, that will be the language that would be similar or analogous to the language by which the dynamics that happens in the universe or in the world. So it became very challenging. So honestly speaking, I tried a lot, years after years, and I couldn't figure it out, absolutely. So the first thing, that the geometric language, what we wanted to invent, I did not get any clue. But as I told moments earlier, that I was struggling with understanding the spontaneous shifting of the resonance frequencies of microtubule. And that is actually, the key point or key discovery moment of my last 15 years of research. Because when I was measuring the tubulin proteins on many kind of proteins, and looking at the spectrum analyzer, the vibrations, and those peaks were shifting. If you send electromagnetic resonance or ion is flowing through the protein and then they're shifting peaks, I could not understand. Much later I understood that where there is a silence, there is the language.
Can I just ask? So imagine this is the microtubule, and the way you're trying to apprehend the microtubule is through understanding their resonance frequency. So you're capturing something. When you capture something, you get a inventory of data.
Yeah, just like heartbeat.
Right.
Just like ECG.
Correct. And that inventory of data, then you try to see if there are certain patterns in those data, because some of them would be repetitive, and then you figure out that there is first of all repetition in terms of, so there are different forms of repetition in terms of sequence, in terms of intensity. There would be different language that you would have developed. And once you did that, you figured out that there are these repetitive things, and then there are these silences also which would be repetitive. And then you tried to construct this as a language. Am I right on that?
Yes. So basically, suppose you are looking at the ECG data and you find that particular peak is is getting silent periodically. Then doctor, of course, understands that some valve need to be repaired or something like that. But if periodically some peaks get absent, some peaks get dominated, then we find that information is over there.
Got it.
What I was doing, but normally when people do research for the last 100 years, when we pump some signal and system responds with some unique thing, unique responses, they take whole response or response at a particular region where they are doing the measurement. They do not look into the shift in response, finding out where response is continuous, but it is making a periodic changes in the response. So it took nearly 5 to 6 years from 2008 to 2014. So 6 years, and then I understood that I am looking at a very wrong place. I have to look into not at the expressions, but silence. For an example, you ask me, or I ask you, Hemant, what did you eat today in lunch? You say, nothing. You could say, nothing. 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 So NOTHING, but you are creating completely different perspective and giving me message completely different.
Correct.
Just by changing the time gap between the letters NOTHING. So the meaning of words is not important. A language is actually manipulations of the silent part, or the burst, gap between the bursts. When I thought that, then I started looking into who are making the groups, who are the peaks making the groups, which are the silences making the groups. Then I find the prime numbers. Then I found they are making, they have a phase relationship between these silence points.
Can you
Explain them? Only way I can explain them is if we consider geometric shape, triangle, square, and then what happens? Each geometric shape, the 3 points in the corner, 3 points. So this point, and this point, these 3 points, they are actually the silent points or the very active point regions in the resonance band, and they are actually moved together and they have a phase relationship. So if this one is a sine cos 30 degree, then a sine 45 degree, a sine 47 degree. So some relative phase differences between the signals, and that they actually maintain. So basically, from the peak variations, I could generate 2D, 3D, and other kind of geometric structures, and that became the foundation of the language of the materials. Because when you are talking to me, I can convert it into a stream of pulses, and I can derive the geometric shapes from it. So I can read it in terms of geometric shapes, and I can send another set of vibrations following that geometric shapes. For an example, you talk to me, I get a triangle. I get waveform and I get a triangle. But triangle, that material will not understand, because you talk in sound. Sound is 20 hertz to 20 kilohertz. So it will not understand. So I convert this frequency into, say, megahertz or gigahertz, where a chemical reaction or self-assembly could activate. So what happens when I send the same thing, a very particular kind of self-assembly activates, but I make sure that when they vibrate, then they generate similar kind of triangle. So this is all about inventing the new language. And it took nearly 2000, up to 2016 to understand how this language would be formulated, how it would be there. So basically, discovery of new language or invention of this new language is one of the biggest foundation. And I think this is biggest foundation of artificial brain building. And I think that this is one of the biggest discoveries.
So I find this fascinating. Whatever you just described, it's amazing. A couple of curiosities that rise is uh, going back to the example that you gave. Suppose if I say something, you can create a triangle, but it's in a certain frequency spectrum. And if you try to give that to the material, there is no intermediation. There needs to be some kind of an intermediate processing of this so that the material can understand this language, and the material has a certain range boundedness in which they can understand this language. So you create a middleware where this spectrum then gets translated in the spectrum that they can understand. Uh, Now, if I hold this right, then what I also understand is at this point in time, as the universe is functioning, uh, there are these different frequencies at different scales or different. And the word scale here is not just a verticality, but let's say all across. And there are these frequency spectrums at all these scales and spans. It's already happening. What you're now trying to do is first understand what these spectrums are, and then trying to see what kind of interventions need to be made to understand the relations and causalities, so that the right kind of frequencies can be then used for making the changes that we desire. Is that the right way to look at this?
Two things I would like to say. First is, you have raised a very beautiful point in the first half of your question. That is, at this very moment, I am accepting your sound, and it is going to my materials in my mind, in my brain, and then it is taking sound as is. And now in your research, why do you need to convert that triangle that I am sending into into the brain jelly language? In the brain jelly language, suppose brain jelly activates self-assembly at different kind of frequencies, then I have to change. Basically, you also do the same. You are listening from me the sound vibration, 20 hertz to 20 kilohertz, but when you send it to your brain, you convert entire thing 1 to 10 kilohertz, 1 to 5 kilohertz.
Interesting.
So you do the same. Right now, we are building the materials. The brain jelly is under development. We built some prototypes, but so brain jelly is our 10th discovery that is described in the chapter 9. That is the final part of it. That's the machine, the artificial brain that we are building. We built a prototype. So when the supreme jelly, the final jelly will be there, so you will just speak with sound, and then it will convert. So you can have materials that can convert kilohertz to megahertz signal.
Wow.
Transducer. And so you will speak to the jelly, and then jelly will speak loudly back to you.
Wow.
So imagine that you have a jelly and a microphone connected to it. You're speaking to the jelly, the transducer is sending the signals, and then the jelly is replying you back.
Interesting. Interesting.
So this is about the language.
Yeah, so there was one curiosity around the language. You described very beautifully the whole journey of how you looked at silence and then try to detect the different patterns around it and develop the language. So I believe languages, you have certain aspects of the language which is like established, and then the language also keeps developing over a period of time. Most of the languages. Does this feature also apply to your language?
Um, I think in our case, we would like to. Right now, we have 15 geometric shapes,
Okay.
which we use, and 47 different primes, so 47 different composition of geometric shapes we use. So it's just like 47 letters we have, 47 words we have, and 15 letters.
Interesting.
Sorry, 15 primes. So basically 15 primes up to 47. 1, 2, 3, 5, 7, 11.
11, 13,
Yeah.
19, 17.
Yeah. So, so in future, I feel that we would like to justify this language as the language of the universe. So we would like to verify it more and more as if universe makes conversation with its elements, planets, stars, and galaxies in this particular language. So we'd like to test this one to interpret the language of any animals, whether we are able to understand the conversation of any animals, conversation of different planets, different fields. So language evolves because the necessity of humans, their demands, their value systems change. Here, the language would also evolve, making it more perfect and closer to the language of the universe. So if it could be that it is already the language of the universe, because we have discovered it from the protein vibrations, but I think that it will be a beautiful thing when we would take this geometric language and explain something astrophysical, something happening in far distant galaxies with gravity wave or something like that. And if we can implement the same language discovered from proteins and over there, that would be the kind of goal, that the dream I have.
One clear thing I think you would have already thought of is there are a lot of scientific discoveries in the past uh, that have been already there and the documented, researched. Could your language reverse engineer and actually go back and develop these theories and arrive at the same conclusions?
We have to do that. Actually, 2010 we published a Nature paper to recreate two physical phenomenon, radioactivity, the theory of radioactivity, and theory of diffusion of gas. These two theories, we try to rebuild it in terms of geometric shapes with cellular automata on molecular layer. We are inspired by the prediction of Richard Feynman that one day the physics laws will be replaced by a checkerboard in which geometric shapes would change each other, and then that will be kind of the language of the true science or the ultimate science or something like that. So definitely, we would rewrite the physics laws using this language. Definitely. After that, the verification will begin, or other people can also do it. A very particular kind of dynamic processes, but that is very easy to do because my previous research was on this topic. So finding cellular automaton rule that will look like radioactivity, that will look like diffusion. It's not a difficult thing to do. So definitely we can. But currently, at the moment, we are concentrating on perfecting it. What are the weaknesses of all the 10 discoveries that are listed in the book, and then what more experiments can be done? Or when we write a book, the biggest problem that we face is that we do not realize that some particular information are very key to make the people understand a particular discovery. We think those are unimportant. We miss it. And after the book is published, then everybody starts complaining like, look, you should have told something about this particular thing, and then we could have understand it easily. Now it is very difficult in this particular format. Then I would say, oh, I knew that. I did it, but
I didn't
I'm
write
going
it.
through that. I'm going through that particular tension, and then also I'm trying to figure out that what are the weaknesses in this already made discoveries. But people of the world can use all these concepts to do the things that you are suggesting.
Interesting. So you said that we today in this episode we would begin the journey of unraveling the 47 important
Yeah, but I have not. We have not already covered the 10
10
discoveries.
things. Yeah. So we began with geometrical
We go to the language.
language.
Yeah.
Next point
The
would be
second, the second would be a new kind of metric. So metric is a Greek word. It means measurement. So by measurement, you mean that you have a scale. Scale depicts a particular distance, and how much distance a metric would depict depends on your choice. And so you say that this much is one Donald Trump, two Donald Trump, three. So unit you decide, okay, and then you make how many of those unit you need. So this particular culture has been going on throughout the world. So all these times there were two different kind of metrics. One was space, another was time.
and there was something observable and there was the numbering system. Both of them have to come together for this, something like this, right? Something observable and something a number system or a sequencing system.
Sequencing system should be there, so you can count.
Yeah.
So in 1915, when Einstein's theory came, general theory of relativity, when he bridged space and time together, then it meant actually when you are measuring the space, how long it is, then you have to how long it is, then what speed you are measuring from here to here. You understand? So this could be a this could be a nearly 8 inch or 8 inch. And here you have to say how long. I mean, how fast you are moving from here to here. So how do you go from here to here? And then the speed is important. Or if you say 1 hour, then you have to say that how much space you are carving, because both are connected. You cannot measure one with the other. So, so in astrophysics, this particular space-time gave beautiful results because the famous Einstein equation E is equal to mc squared came like this, and then many things happened. But We never wanted to again, but we had to introduce a metric for consciousness, for artificial brain, to measure the change of state. Change of state. The biggest problem is when you all the scientists struggled a lot in explaining a conscious state. Explaining a conscious state is very, very difficult because free will. Logically, you will ask me, now I would like to talk to Hemant, and then I decide, okay, I quit, I will not talk. Where this decision is coming from, absolutely logical, but where does it come from? We don't know. But we want to formulate it. So what we did, we found that inside the brain, we found 12 layers. Brain structure we have, and then if we go inside, we find some other dependent key functionaries. We go inside, we find other key functionaries, 12 layers. So when we are going one layer inside another layer, inside another layer, inside another layer, we found 12 layers. And 12 layers, when you go inside, it has a striking similarity with the 11 dimension or 12 dimension. And we were also trying to find out what are the key prime numbers being used. Then we found 10 to 12 prime numbers are always being used in microtubules when it was setting the vibrations in the neurons, same things were happening. So since the year 2014 to 2016, 2017, I mean, we were extremely, extremely concerned about how to put these things together. In human perspective, when we are making decisions, space and time come together. That we know. Because, when you are very much tensed, then time does not pass. You feel like time is not passing, time is not passing, time is not passing. So if you want to draw a conscious state, it could be fun to include space and time. And when we are looking into different dimensions, then we found that time is not everything, Suppose you have a clock and you are going from here to here. It could be that each unit of 1 second at some point of time, your time gets undefined.
Can you explain that again?
Often, for an example, you and me talking to each other, every 200 milliseconds, our conscious experience is built. So 200 milliseconds, if you have a camera which could take a picture faster than 200 milliseconds, much, much faster, you will find I'm a zombie. So if you could take 1 million pictures, you'll find something like that. So our brain takes time, 200 milliseconds to generate the conscious experience. It needs to do a lot of hard work, back and forth this way, back and forth this way. And then, it has been very well studied, and then how much time in which part, and then all are documented. So we found that we have to go give time some other dimensions. So you have to go higher dimensions, just like imagine you have a sphere and you have an ant which is moving all around and calculating time. So it's not a space, but it's a time. But time is a sphere of time, and on top of that you are moving. So in this way, higher dimension of time, on which surface time is being measured, based on that a time will be different. So we added another dimension, space-time topology. And then when you have a topology, then fixed topologies are there. So fixed ratios will be there. Fixed transitions will be there. So we get into primes. Because geometric shapes have restrictions, and then restrictions is very well modeled by primes. So eventually it becomes an 11-dimensional journey. Space, three dimensions. Time, 3 dimensions. Topology, 3 dimensions. And prime, 3 dimensions. Totally 12. So using 12D tensor, we call it duodecanian tensor, we represent the whole thing. And basically you can say it's 11 dimensional. So this is how the journey of a new kind of metric started. But it's very, very beautiful how you think that you had space, you had time, you had topology, you have prime. So now your metric is independent of any unit.
So you mean to say there is no unit per se?
Not any unit anymore.
But when you want to so what you just said was there is space. There are three. There is a triangle for space, triangle for time. There is a triangle for topology, and there is a triangle for prime, right? And this makes it 12, but 12 different nodes, if I may use this word right now. And at any point of time, whatever you're measuring with this would give a value. It would give a value. And then if we put different values, there would be some unit to it, right?
So basically, whenever you are measuring something, then you have a unit, and based on that you go on.
Correct.
And we call it pattern of primes, phase prime metric, and then we have talked about it already several times, that a temple-like architecture made of primes, where x-axis is integers and y-axis is number of choices, all possible choices in the y-axis. You rotate this and you get a temple-like architecture that contains all possible solutions of a problem, and that temple-like architecture is our phase prime metric. And then when we say that space, time, topology, prime, basically we get certain values independent, or some primes as output, a set of primes as output, or the measurement for a particular event to happen anywhere in the universe. So basically, if somebody, for an example, a particular code when you send in a secret language from one country to another, what happens is that code goes from one country to another, and then you know how to read the code, and then you extract it. Suppose you are the universe and you have been asked to operate different events of the universe. What you would do? You have to make it independent of space, independent of time, independent of topology, and because you are the universe, so you should be bias free. Even topology is biased. So you you find, okay, you work with, you want that kind of events? Okay, you work with prime 2. Okay, you work with prime 3. So as a universe, you need a metric so that you can send. And when the metric translates it from the primes. It gives you the topology, the kind of topology that you would be using. It gives you the kind of time flow and then the space. So where it would happen, how the things would unfold, one can just use this metric to find out. The space-time-topology-prime. So it's a big jump from the earlier ideas of Einstein, where space and time was there. But here to do the computing, whether universe follows this space-time topology-prime metric, we don't know. We are not even concerned about it. We are concerned if this helps to build a universal computing system where we would like to test that we send certain primes and start building a whole set of events or control regulatory set of events.
Yeah. So Anirban, you mentioned about space-time topology and prime, right? Can you expand a little bit on topology? What exactly do you mean by that?
Topology means normally in the geometric language we say 15 geometric shapes are there. This topology is not that. This topology is actually you can take those 15 geometric shapes, but what happens here is that on this particular 3D surface is actually where the time changes.
So suppose if we take this as an example, this pen as an example, can you give an example of what question you would craft and use topology on this, the concept of topology on this?
Basically, if this is a cylinder, and then suppose some object moves homogeneously through it. So for it, when it moves along the length, then its time would be changing in one rate. But when it will be carving at the top of the pen, then it will be extremely slow. And then because it is going to higher dimension, another dimension, it want to spend the same time along the length. So it's very fast and then very slow. Answer? Slow. So it is keeping the same distance in all times. So when you apply principles of time spending, then topology actually determines the non-linearity of time, or the time, how it flows.
Okay.
It governs the basic change of time. So time crystal and all other things are that we have created a model, time crystal model of the whole human brain. Those are actually an output of this.
Okay. Okay. Go on. Sorry, you go.
Yeah. So basically, this particular metric, initially we thought that astrophysics has got a metric, and astrophysics gives a huge insight when we solve the different metric, Schwarzschild metric, and then different kind of metrics were created to find the space-time and then other kind of curvatures. But it could be that human thoughts are like manifolds. Manifolds means just like lotus or many complex flowers. You have petals here and there, here and there, here and there. So many different dimensions, and then they are connected here and there. And then if you try to put them together, then they speak. They give different dimensions of very particular kind of process. So human thought for us were manifold. So we published a paper that if we write down all the geometric shapes in terms of information in terms of time crystals in the tensor, how the manifolds would look like. So earlier, how the human thought looked like, we never had any idea. But now we say that two-dimensional, 2x2, 4x4, 5x5. I mean, how many layers you go inside and inside and inside. to construct an event, to understand the architecture of confusions. And third world, there something happened over there. If you go first layer, second layer, third layer of an event, you go to the seventh layer and third layer, they interact. And then 15th layer and then 9th layer, they interact. And then they affect the 5th layer. So this is kind of a journey through manifold. Journey through manifold is a very interesting, and it is, George Gamow wrote a book, Mr Tompkins. Tompkins story. He goes to a very different kind of world where G is very low. So what happens to him? So it's a very nice story. Similarly, so that's or a person goes to the world where velocity of light is very low, say 30 meter per second. So you cannot run a cycle more than 30 meters, say 30 meter per hour or something like that. It's very,
everything's lower than the speed of the light there.
Yeah, below light. So how the world would look like or something. Such a funny story.
Yeah.
So even much more funnier things happen, because what happens is that somebody in the seventh imaginary world does something and something happens to you here.
The butterfly effect kind of thing.
The butterfly kind of effect, but you are affecting that is affecting that is affecting that, and everything is collectively coexisting.
Interaffecting kind of
thing. Yeah. So this is kind of living in a manifold. So yeah, please.
So you mentioned about thought in the paper that you published. Did you define thought?
We actually, what happens is that in all the paper that we have published, also in the book, we have tried to define everything in terms of scientific parameters, so that people could reject our views. So thought, I know that many people don't define it. So for us, thought is a manifold, a 12D manifold, or a transition of this metric, space-time-topology-prime metric. On this metric, it's a manifold. So normally space-time topology gives you a curvature, but space-time topology prime gives you some locations on the phase prime metric or somewhere like that, from where you can build up the manifolds or many evolution of manifolds. Basically, yeah, evolution of manifolds, set of events or chain of events that can happen. So that is basically the thought. So we have mathematically defined it.
Okay.
It's in the
paper. We can give the links to the paper in the
yeah. 12D manifold is there. Also, it is in the book.
Okay. Please go
on. So this is basically a way to put all possibilities of combining geometrodynamics into, geometric dynamics by which maybe universe is being governed, into one systematic structure. You can say something like grand unification theory of intelligence or natural intelligence.
I almost thought about it. I say the moment you're saying it's a universal language, I was wondering, is it theory of everything?
Yeah. So basically, all that we have tried is to build an artificial brain the way we could implement it. But time to time, we found that we had to adapt several theoretical proposals and mathematical modules from astrophysics. For an example, we wanted to have a 12-dimensional tensor to represent the human thought. And then what we did is we tried to see 4 dimension, 4 imaginary world, 8 imaginary world, those kind of mathematics existed. So initially we went to the different mathematicians to learn about it. They said, no, you can't. It's very, very difficult. Then we came back and started building. They said that string theorists, they add 4-dimensional world and then 8-dimensional world and wrap them together to create the 12-dimensional world. So why do you want a pure 12-dimensional? Well, no, not just 12-dimensional. I want 2-dimensional, 3-dimensional, 5-dimensional, 6-dimensional, 7-dimensional, 9-dimensional, 10-dimensional, 11-dimensional, 12-dimensional, 13, 14, 15, 16, 17, 18, 19, 20. So why not?
Why is it important to have these different dimensions?
Because when you are, for an example, suppose in the brain, when we are looking into it, there are layer inside a layer inside a layer inside a layer.
12 you mentioned, yeah.
Yeah, 12 I mentioned. Suppose you have a neuron. Inside the neuron, the filaments are there. Inside that, you have a water channel, you have protein layers, and then inside the protein, you will find water channels and then secondary structures. In the secondary structure, you find molecular layers. So just from neuron to the secondary structures, you find 5 or 6 layers. And then if you go neuron and above, you find 5 or 6 layers. So if you have 12 layers, so you need 12 dimensions. Now 12 dimension you can have in 2 different kind of geometric shapes. Dodecahedron that has 12 planes, 12 pentagons connecting to each other, or you need an icosahedron, just 12 corners. Just like cube has 8 corners, so 12 corners, and then 20 planes. So that's why we go up to 20 and up to 12. So basically, we wanted to have a self-operating mathematical universe that could be analogous to a human brain. So human brain, whatever the human brain does, it should do. But at the same time, I cannot leave it in space-time. I have to go to space-time-topology-prime so that I can go to the phase prime metric, because primes generate naturally. So if you put random oscillators, they will vibrate and follow phase prime metric, because there is no other choice. Because phase prime metric means you have number of participants and all possible choices. That is a temple-like architecture. So I always try to bring every single concept, whatever I needed, to phase prime metric, to put towards that direction, so that what happens is it becomes self-operational. Self-operational was always the driving force behind every single discoveries that we made. So that's why it was necessary.
Could it be possible that a scientist or any person could just put forth an argument to you saying that because you continuously kept getting good outcomes for applying the phase prime metrics, you continued to apply it to everything that you did. How did you ensure that it was not a confirmation bias?
Bias towards the phase prime metric.
Exactly.
So phase prime metric was discovered from the protein vibrations and then those kind of choices where I found that those things are occurring.
So it was a natural observation-led kind of thing.
Phase prime metric was not discovered by me independently to build a computer.
Correct, absolutely.
So what happened is that when I observed that experimentally and then discover it from a particular system, it's natural for me that I will try to find that whatever the system mathematically I build, that so that contains the concept. For an example, geometric language, it should contain geometric language. It should contain phase prime metric. Then that's why space-time-topology-prime metric I had to introduce, because the experimentally derived observations should not be ignored.
Okay.
So felt like something should be there.
Okay, fair enough.
The number 3, the new mechanics, the fractal mechanics we proposed. We never wanted to go beyond fractal, beyond quantum mechanics, because Roger Penrose had been arguing for going beyond quantum mechanics many times, but he never said what is that. I think that at least we should lay down the proposals and then formulate the things, and then people would decide. At least if you do not say what it is, nobody can disprove you, right? I mean, that is not the progress of science. So progress of science means you have to lay down the proposal in such a way that people can debate on it and discredit. Yeah, it should be falsifiable, must. Yeah. So that's why, the problem that happened again, brain had 12 layers, one is inside another. And then the problem was that if it is, and then at the 12 layer, when we develop the Dodecanian algebra, that is also a completely new kind of algebra that we had to develop, because you have material inside a material inside a material inside a material 12 times, just like the brain has, then the dynamics will be very different. Classical mechanics won't work, but a quantum mechanics, you have one imaginary world, fine, but you have many imaginary worlds, that is also fine. But when you have many imaginary worlds and they are interacting with each other with multiple coexistence of solutions, for example, 12 layers are there. So 12 layers, you can combine 2 into 2 into 3, 2 into 3 into 2, 3 into 2 into 2. Many different ways, 3 different ways, distinct ways you can integrate those worlds and then create a completely different kind of results. Then what do you do? That kind of mechanics cannot be explained by quantum mechanics that is formulated till date. It does not address the issue of interplaying of imaginary world. Yeah.
Till now, what you explained, Anirban, was one is, I heard you, and I'm just laymanishly structuring this, is the structure of the brain. So you said there are 12 layers to it. So I hear the word structure there. And then when you use the word thought, it's very subjective. And you try to use a particular mechanism through your theory to apprehend them and capture them and predict them in some sense.
Yeah.
Okay, fair enough. Go ahead.
Yeah. So it is like this. You have a hardware that is your brain. So people have tried to create a spatial map of the brain. It's called connectome. Then Broadman also looked at the cell nature, and then he created Broadman's map. So many different kind of maps of the human brain got created depending on what question you ask. So we ask a question that we want you to operate by yourself. So we want to map you as an architecture of clocks. That's the idea.
Can you expand that a little bit, because I didn't quite understand what it means.
Yeah. So suppose you have a clock. Clock runs by itself.
Absolutely.
Suppose every single system that is in your brain, we represent it in terms of clocks.
Okay. All the 12 layers, let's say.
Everything.
Okay.
So like people said that if I copy all the neurons exactly in the way it is in your brain, then I will be able to upload your consciousness.
Yeah, the only thing is, at any point of time when you're apprehending it, you're only drawing a correlate and not exactly the neuron. You're trying to look at the observable thing and trying to copy it.
No. At this instant, atom by atom, I replicate your brain.
Or you're saying the substrate also, not just, so it's substrate agnostic, you just copy it with a substrate.
Absolutely. Okay. Absolutely. The whole material, if I copy, and I will be uploading, recreate you.
Okay. And then?
That's why they replicate it. I'm saying that it's very difficult. If you do atom by atom copy, you need to do it simultaneously, whole thing, because you are talking about spatial map. You are not talking about the temporal map. You get it?
Yes, yes.
I'm saying that whole world, every single scientist who said that just by copying atom by atom, all the elements of the brain. You can rebuild an artificial brain. You can upload human consciousness and humans can live forever. They are all wrong. They can never do it because temporal map is not copied in that way if you copy the space. Okay. So that's why we came up with the time crystal model of the whole brain.
And that allows you for a temporal copying?
Yes.
Okay.
Okay. But that is not enough. So just now I said space-time-topology-prime. So your brain, you have a spatial map that is whole world is trying to copy. We are trying to build spatial plus temporal. But that is not enough. By studying the dynamics continuously, we have to find out there is another topology is there where the times are being mapped. So I need that map also. That is the hidden topology everywhere. And then the primes, the phase prime metric, because those are infinite series, where it is oscillating with a very particular pattern that is not visible in normal temporal map. You need to look at how the temporal map is evolving. You need to go to the higher dimension. Only then I can copy your consciousness.
So what you're saying is you agree to the whole idea of copying. So that's one feature which is common between your approach and their approach. But what you're saying is what is getting copied is there is a distinction. While the existing popular approach is the spatial copying, you go and you add three more avenues to it, which is temporal copying, topology, and then the prime.
And then prime.
Okay.
Basically, phase prime metric we need to, and then the topology used to map the time.
How can one, just as a layman, falsify that this is like? Is there any way where we can falsify that these three are needed or not, or they're the right things?
Yeah, only way to do is to build it. We are trying to build such systems, and we have to see that whether they are self-operational or not. Okay. If they are self-operational, then definitely this is the truth, and if they are not self-operational, then it is not. Because now in the book everything is out.
Okay.
Now everything could be tested because these are very clear-cut mathematical statement. No, I mean falsifying is very straightforward.
Got it.
Very straightforward because moving to higher dimensions. How to go to higher dimensions in the chapter 2 we have said that you just ask who jumps, point to point jump, you get a straight line. So 0 dimension to 1 dimension, straight line to another straight line, you jump, you get an area, 2 dimension. 1 area to another area, you get a volume.
Right.
Volume to volume is changing. You need time, 4th dimension. So 3 dimension, 3 space, finish. 4 time. If in time sometimes becomes undefined, you go to the higher dimension. You get time crystal. Then time crystals, many singularity points, they map on a topology. You get another higher dimension. So 4, 5, 6 done. Then 7, 8, 9. When you have say higher dimension of things, then you go for topology. And that topology again goes to higher dimensions, and then higher dimensions, and then you go to the integer.
Interesting.
So this is how you create. So when we define even how to build the higher dimensions, then it's not difficult to disprove it.
Okay, fair enough, Anirban. Go on. Sorry.
So basically, we are suggesting that 4 simultaneous, complete, comprehensible maps are necessary to upload human consciousness. So spatial, temporal, topological, and prime.
Interesting. Interesting. And once you're able to do this, are you also saying that this would make humans predictable?
No, it's not make humans predictable, but you can make human-like.
So you would create another human in some sense.
Yes.
So Hemant still continues to be Hemant with whatever characteristics and features we will call as Hemant. But there is another.
Hemant we can create, but both the Hemant will interact with the environment and would then evolve in a completely different direction. But because they will experience different things, different ways, there will be similarities, but they will continue to depart.
And okay.
Because your spatial remains same, temporal remains same, topology remains same, but the prime level slowly, because that is infinite series where your projection from infinity and feedback in infinity, those dimensionless changes are happening of your experience. So even if you have the same hardware, slowly it is going to change.
Okay. And are we also then saying that this new person, let's say Hemant, can be imparted features of a superhuman?
That is a different part of the. So in the chapter 10, we have described how we will create aliens or G++ or the much more powerful human beings who have much more superior consciousness. It's not a. So like 12, 2 into 3, 2 into 3 to 2. The 3, I said that one Hemant hardware has 3. What if one Hemant hardware has 9 Hemant souls? Then 3 of them, 3 Hemant here, 3 Hemant here, and 3 Hemant here will make a topology, and those 3 will make another topology, right?
Yeah, yeah.
So that means a Hemant living in the planet Earth have 3 souls, 3 Hemant. Another Hemant got created with 9 souls in somewhere else, and he comes here, and then he has topology of topology. That means it has thought process, complicated simulations in which he can easily understand what this Hemant is doing. But this Hemant, the planet Earth, with 3 spontaneous things, even if with its ultimate ability of consciousness, is not able to even fathom what this 9 soul Hemant is doing. So independent information architecture could happen if you have, if you build the brain, now in this case 12 layers, if it is say 30 layers.
Fantastic.
So 2 into 3 is equal to 6 into 5, 30. So 2 into 3 into 6. So 2 into 2 into 3, you can create in 3 ways. 2 into 2 into 3, 2 into 3 into 2, 3 into 2 into 2, because 2 and 2 are similar. But 2 into 3 into 5, you can create 2 into 3 into 5, 2 into 5 into 3.
3 into 2 into 5, 5 into 3 into 2.
You can do it in 6 or maybe more. I have to check.
Okay. Okay.
So many different ways. So that many souls will exist. That many band will exist.
Interesting.
So layers one below another, and 30 different kind of systems. Each could be conscious, its own ability.